Good morning, everyone. New tie, new day. Greetings from Germany. We're going to work today on solving equations, or as my German physics professor said in undergrad, solving equations. Shall we? First thing you know is you need to be able to group like terms, and second thing you need to be able to do is to undo whatever other operations are in place. I'm doing the inverse. Let's see an example. What about 2y plus 3 equals 7y minus 5? A lot of ways we can go here. Let's take the 2y, pull him over. Pull him over. To undo addition, I do subtraction. Subtract the 2y. I've got 3 equals 5y minus 5. Now I need to undo this subtraction. Therefore, better use addition. Done there. 8 is 5y. The last thing I need to do is to undo this multiplication. So let's divide. There it goes. And I'm left with 8 over 5 equals y. Got a quiz. Box your answers. Box them. Box them. All right. Up next, what if I'm not solving an equation that's so simple? What if I need to solve for an unknown quantity amongst other unknown quantities? You just heard me say box. Let's box them again. Let's say I want to solve for h. Let's put a box around the h. Are there any other h's I see? At the moment, no. So that we're good there. Once again, I need to group like terms. Does this have an h? No. So let's subtract it. So I'm going to have s minus 2 pi r squared equals 2 pi r h. Keep the box. Last thing, I need to undo this multiplication. Let's divide by 2 pi r. Divide the whole thing. What? The whole thing by 2 pi r. And we're done. I've got h equals s minus 2 pi r squared over 2 pi r. Call it a day. That is about all you need to know for section 1.4. Group like terms and undo the operations to get to where you want to go. In the end, I'm always making sure I only have one copy of that variable that I'm looking for. Good luck. When we look at equations, we're often interested in when these equations line up or when they're equal. In this case, we might look at the cases where two equations are always equal, sometimes equal, or never equal. Now, while I go and think of some equations and some good examples to give you, I wonder if another department would also be interested in this. Always, sometimes, never. In the English department, we say always wear a blazer every day to work. Sometimes. Sometimes. This question, to be or not to be, that is the question. Whether 'tis nobler in the mind to suffer the slings and arrows of outrageous fortune, or to take arms against a sea of troubles, and by opposing end them. Never, never end a sentence with a preposition. Otherwise, people won't know what you're talking about. Oh God, I've done it. Away!
So coach, are these teams we're playing any good? Always, sometimes, or never?
Let me tell you something about always. Rule number 1, always beat Bocelli. Rule number 2, sometimes as a coach, you gotta wear a tight shirt to show them you can play ball too. And never forget your whistle. It ain't here that makes you a coach, it's right here. Take that to that math department and see if that adds up. Hey gang, much like you, there's a lot of things that I like to do in math where you can make a game of it. We're talking in this case about always, sometimes, or never. Now I don't mean the party game where you sit around and say, hey, I always do my homework. You too? Yeah, I didn't think so. In this case, we're talking about whether equations are always, sometimes, or never equal. Let's look at two cases that are a little more fun than the ones we normally see. When I look at these two guys, let's play the game with the left-hand side. If you use the distributive property, you probably notice that letting this 2 go to each term gives me 2x plus 6. Well, what do I notice on the other side? I also have 2x plus 6. In this case, these equations are always equal. In fact, these equations are meaningless if you were to solve them any further. Now, how could you do that? Well, if you tried to solve them, you would get 2x equals 2x. Once again, if you get the same thing on both sides, doesn't matter how complicated it is, if it looks exactly the same, then these equations are always equal and in some ways meaningless. What about this? What about 6x minus 5 equals 3 times 2x plus 4? Maybe you want to take a minute and work on this side to see what happens. Go ahead, you can do that. I'll do it as we go. On the left, we've got 6x minus 5. On the right, we should have 6x plus 12. Over here, if I try to get rid of that 6x that I see on both sides, let's see what happens. If I subtracted 6x from both sides, I'd have negative 5 equals 12. Now, in no possible world that I can imagine does negative 5 equal 12. If you can think of one, how about I give you $5 and you give me back 12? We'll see how that works. Otherwise, we wouldn't say that these equations would ever be equal. In this case, we would say they are never equal. In the case of when the equations are sometimes equal, that's when we can solve them just like normal. So I left that case for you to work out on your own. Good luck.